Associated with every square matrix is a number called its determinant. In this section we'll talk about how to calculate the determinant of square matrices, and in the next section we'll talk about how we use determinants. Well, if the matrix that we start with is a little 2 by 2 matrix like this, then the calculation for determinant is rather simple. Now the notation for indicating determinant is this. We're going to calculate the determinant of matrix A, and another way to show it is like this, with what looks like absolute value symbols on either side of our matrix entries. And this is not absolute value, of course. It means determinant of the matrix indicated with these entries. Now the calculation for determinant is particularly easy when we are just dealing with a little 2 by 2 matrix. We actually multiply the entries along this diagonal and subtract the product of the entries along this diagonal. So it would be 2 times 4 minus 3 times 1. So 2 times 4 minus 3 times 1, or 5, as the determinant of this matrix. Now I know at this point that it seems like this can't possibly have any usefulness, but we'll see the great usefulness of determinants in just a little bit. Let's concentrate now on how to make the calculation. All right, another little 2 by 2 matrix. Here's matrix B, and here are the entries for the matrix, and here's the notation for the calculation of determinant. It's one of these or the other. We don't have to use both. But the calculation is made by multiplying along this diagonal and then subtracting the product along the other diagonal. So it's negative 4 times negative 1 minus negative 3 times 5. Just write down what you're doing and then simplify carefully. We find the determinant to be 19. Now when we move to higher ordered square matrices, the situation becomes quite a bit different. Consider a 3 by 3 matrix, and we're going to calculate its determinant. There are actually 2 methods that I'm going to show you here. Now one method applies only to 3 by 3 matrices. The other method is general and can apply to higher order matrices. All right, here's the one that applies only to 3 by 3 matrices. Now this one also involves multiplication along diagonals, but it's a little more complicated than the one before. Now to calculate the determinant of A, we indicate it like this. But here's what we're trying to do. We would be finding this product and then adding the product of these 2 entries and that one, and then add the product of this entry with those 2, and then we want to subtract this product and subtract the product of these 2 entries with that one and the product of this entry with those 2. Pretty convoluted, isn't it? Well, we can clear it up a little bit by doing this. All of these products can become much more clear by taking the entries within the matrix and just repeat the first 2 columns. And then we're dealing with kind of straight line items like this. The 0, 3, 4 and the 2, negative 1, 0, I'm just going to repeat those columns out here. So 0, 3, 4, and then 2, negative 1, 0. And now we proceed like this. It's the product of these 3 items and these 3 items and these 3 items, and then we want to subtract the product of those 3, those 3, those 3. So we would write the entries down like this. We would say, okay, this determinant is found by taking the product along this diagonal. That's 0 times negative 1 times 1. That's these items, you see. And then we want to add the product of those items, 2 times 2 times 4, and then add the product of those items, 1 times 3 times 0. And now we're going to subtract a number of products. Okay, so we're subtracting all of these products. 4 with negative 1 with 1. That's here. And then 0, 2, 0. And then 1, 3, 2. 1 times 3 times 2. All right, and then of course the smoke can clear on this very quickly when zeros are involved. Those items just go out, and under normal circumstances we wouldn't even write those products if a 0 is involved as a factor. So this goes out. We have 2 times 2, 4 times 4, 16. This rascal goes out. So we have 16 minus, and then in the brackets we have 4 times negative 1 times 1. Well, that's negative 4. This goes out and this becomes 6. So we have 16 minus, and then bracket negative 4 plus 6. This is 2, so it's 16 minus 2, or 14. Okay, so that's the situation. You just take the entries in the matrix, repeat the first two columns, and then multiply along diagonals and get your sign pattern correct, and it's pretty much a piece of cake. Now, let's look at the other method. Now, this is the more general method. This is the one that applies to higher order matrices. And at first it seems more complicated, but then you find out that it's actually a speedier method under many circumstances. All right, it involves this. It's the notion that we have here the determinant of A, and here is A. Here's the same matrix that we had before. We're taking the same determinant. All right. We're also going to multiply here, and we're going to multiply entries along any row or any column, each entry times an item called its cofactor. And I'll tell you how to determine the cofactor in a minute. But the important thing at first is to realize that we could go along any of these rows and do this, or any of the columns and do this. We're going to do it actually two ways here, but the first way we're going to do it is just go across the top row. So it's going to be the entry 0 times an item called its cofactor, and then we want 2 times its cofactor, and then 1 times its cofactor. So that's the general idea. Now, what is this cofactor business? Well, a cofactor has involved with it the determinant of a small matrix, and also there's a sign pattern involved with it. All right, let's determine this. Let's identify this determinant notion first. Now, the cofactor involved with 0 is found by doing this. Now, look at the entry 0. Now, imagine taking out the row and column involved with 0. Just take it out and imagine those not being there. What's left? Well, -1, 0, 2, 1. You see, and it's the determinant of that matrix. You see, that little 2 by 2 matrix that turns out to be its cofactor. Now, I mentioned that there is a sign pattern here that's important. That sign pattern, let me write it up here. I'll write the sign pattern that's important up here. It's plus, minus, plus. It's just an alternating pattern all the way across the array of numbers. And then minus, plus up here, and then minus, plus, minus, and then plus, minus, plus. You see, alternating sign pattern. So when we're going across the top row like this, it's the sign for the cofactor is plus, and then the sign for the cofactor of this item, the item in that position, is minus, and then the sign associated with the cofactor in this position is plus. So once we bump into this second item, you see it's 2 times the cofactor, but the cofactor has a sign involved in it and a determinant. Now, it turns out, and I don't want to introduce too much complication here, but it does turn out that the determinant part of it, this little part, is just called the minor associated with that entry. This is the minor, and when you put the sign with it, it's the cofactor. Okay, I like to think just of cofactors here as having a sign and a determinant, and that's all we have to worry about. At any rate, the determinant part of the cofactor is found by taking the entry 2. Now imagine the row and column, take out the row and column involved with the 2. Take that out. And what's left? Take those out and you have 3, 4, 2, 1. So it's 3, 4, 2, 1. That's how we find that. And then 1 times its cofactor. Now the sign associated with the cofactor is plus from up there. And you take out the row and column involved with the entry and you're left with the 3, 4, negative 1, 0. 3, 4, negative 1, 0. Okay, and now you go back and you make the calculations for those little determinants. That is, we have 0 here, and under normal circumstances we would just take this out right away. I mean, we don't need to make this calculation because who cares what's here? If 0 is a factor here, this baby's going out. So, but just for emphasis here of the method, I'm showing how we make the calculation for the determinant. It's -1 times 1 is -1. And then minus this product, which is 0. So it's simply -1. And then the minus sign here translates to a minus sign here, so it's -2 times. Now the determinant here is 3 minus 8. You see 3 minus 8 is -5. And then here it's 1 times 3 times 0 is 0 minus -4. But minus -4 is simply 4. And now this term goes out and we evaluate performing operations. Negative 2 times negative 5 is 10, and 4 gives 14 as expected. Let's go through the process another time. Now remember, we can go down any column or across any row. Now, in the previous situation, we went across the top row. But here I see another 0, and just for practice, let's use this 0. You see, we get some mileage out of using the 0 entries because items go out algebraically, and it makes life easier for us. Let's go down this column. So here's what I'm doing. I'm thinking 2 times cofactor, so it's 2 times. Now, I've got to think about the sign pattern here. Oh, well, I'll march up over here and reproduce that sign pattern I had attached to the other one. And it was plus, minus, plus, and then minus, plus down this way, and then plus, minus here, and then minus, plus, just a alternating sign pattern. So I'm going down this column, and so I'm using that sign pattern. So let's see, the sign, minus. All right, and now the determinant, let's see, the determinant. We take this item 2, we take out row and column involving that 2, and we have the 3, 4, 2, 1. 3, 4, 2, 1. And then plus. I say plus, you know, we're just kind of adding as we go, but we're adding, and here's the negative 1 factor, and the other factor involves a sign and a determinant. Okay, the sign involved with this entry from over here is plus. So I don't need to write anything. And now the determinant, take out row and column, and we have 0, 4, 1, 1. And then boom, we're down here with 0. And so it's plus 0 times, now who really cares what this is? For emphasis, I'll put it in this one last time, but generally we wouldn't even write anything here because we don't need to. So it's times, let's see, the sign associated with the entry is minus, and the determinant is, let's see, the determinant of a matrix, take out row and column, and we have 0, 3, 1, 2. So that's the idea. And then back over here, we start to make the calculations. We have, let's see, this minus sign now, I'll just put over here. And we have, this is times, the determinant is 3 minus 8. 3 minus 8, that's negative 5. And then here we have, let's see, negative 1 times 0 minus 4, negative 4. And that rascal goes out. So we simplify here, this becomes 10, and then plus 4, 14, as expected. To calculate the determinant of this matrix, we would notice that there are a number of zeros here, all in the same column. So we would elect to go down this column in calculating the matrix. So it's simply 3 times its cofactor, then plus 0 times its cofactor, 0 times its cofactor, 0 times its cofactor. So all of those terms go out. So it's 3 times its cofactor. Now, the cofactor, though, is the determinant of, well, let's see, and we have a sign situation here to deal with, too. And notice that for the 3, the sign pattern is plus, minus, plus. So it's plus the determinant of the matrix that we get by taking out row and column, and we have the entries here, here, and here. And I've entered those right here. So it's 3 times this. Then we look at this. We put our head into this situation. We see a 0 here. We want to involve it in the calculation of this determinant. And I've elected to go down this column. I could have just as easily gone across this row. Well, let's see. If I go down this column, I've got negative 1 times, now let's see, I have a sign pattern here. I have the plus, minus, plus kind of situation. So I've got plus right here, and so that's why this is understood to be plus. And now take out row and column, and I have the 2, 4, 3, 2 right here. And now I'm coming down this way, so it's 0 times, well, who cares what it is? That's just going to go out. And then I'm continuing down 3 times. Now, sign pattern for the 3, well, let's see, plus, minus, plus. So it's 3 times plus some determinant. Well, the determinant is the 1, 2, 2, 3. And here's the 1, 2, 2, 3. So here's what we have. Now this rascal goes out, and we have negative 1 times, let's see, 4 minus 12 is negative 8. And then skip this. This is 3 times 3 minus 4 is negative 1. So this is 3 times negative 1. And then cleaning this up, this is 8 minus 3 is 5. 5 times 3, 15. So 15 then is the determinant. We get a lot of mileage out of having multiple zeros in our original matrix. Here's another situation. It occasionally comes up. I want to show you what happens if we have a kind of a triangulation of zeros. Now notice here's the main diagonal, and we have zeros completely above it. And what I'm going to show you works in situations where we would have zeros completely below the main diagonal. But let's just suppose we don't know that there's any pattern associated with this, so we would probably elect then to involve the 3 zeros maybe at the top of the matrix. So now we'll have 4 times, let's see, the determinant associated with 4, or the cofactor has a sign. The sign is plus because of this position. But then the determinant part, take out row and column, and we have this. All right, so it's 4 times all of this. Now, for the determinant of this rascal, once again, we see the nice zeros across the top. Oh, let's use this top row. So for the determinant of this matrix, then we have minus 4. And now the sign here from the sign pattern is plus again, so that's not a real factor here. Take out row and column. We have the negative 1, 3, 0, negative 1. Negative 1, 3, 0, negative 1. So we have this. Now, in calculating this determinant, since it's a 2 by 2, it's just this product minus that one. And notice that it's minus 1 times minus 1, negative 1 times negative 1, and then minus 3 times 0, which goes out. Now, I'm going to emphasize that these two items are the factors involved in making the calculation, simply because look at the 4, negative 1, negative 1. Those are precisely the items that are along this main diagonal. You see, that's the idea. That's the shortcut. That instead of going through all of this business, that when we have this triangulation of zeros, either above or below the main diagonal, all we need to do is multiply the entries that are along the main diagonal. So multiplying those, we find this determinant to be negative 16. Here's another situation where we can gain some efficiency using a certain particular little method. Suppose we have this, and we're noticing that, gee, we don't have zeros, a whole bunch of zeros anywhere. Of course, we could go along this second row and gain some mileage out of that. That's what we would do if we were using the process from before. But what we could do here is create a situation where we have multiple zeros in some row or column. And we can do that pretty easily here because we have a 1 in this row. Now, whenever you have a 1 in a row, you know, our row operations can kick in here, and we can cause other rows to change accordingly, and I'll show you that in a minute. But there's one thing now you don't want to do in performing row operations, as we did before with matrices, and it is to swap 2 rows. If you swap the entries in 2 rows, then you're sort of changing the sign pattern, or you're in danger of changing the sign pattern. So I would simply steer clear of that technique. But here, if we want to create zeros in this position and that position, we already have a 0 here, then we can do that by operating on these 2 rows against this one. That is, to cause a 0 to occur here, then we can say, all right, let's multiply in this row by negative 3, and then add row 1. So it's negative 3 times row 3 plus row 1. So we indicate what we're doing here. We perform the operations, and we get these entries. Now notice that it's negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1 is negative 3 plus 6 is 3. Negative 3 times 2 is negative 6 with negative 5 is negative 11, and so on. All right, in a similar way, we can cause the entry in this position to become a 0 in the next step by working off of this 1. It would be 2 times row 3 plus row 2. So we indicate what we're doing here. 2 times row 3 plus row 2. That's 2 times 1 is 2 with negative 2 is 0. 2 times 1 is 2 with 0 is 2. 2 times 2 is 4 with 6 is 10, and so on. All right, now that we have this situation that we're after with multiple zeros, we can then use our idea for finding our determinant by going down this column. All right. So we would have 0 associated with a cofactor, it's gone. 0 associated with a cofactor, it's gone. and then 1 associated with its cofactor. Well, what's the cofactor of this 1? Well, we need to consider the sign pattern, and the sign pattern here would be plus minus plus. So we're in good shape there. And then the determinant then is of the matrix, which is take out row and column, and we have the 3, 2, 3, the negative 11, 10, negative 1, the negative 2, 4, negative 1. All right, now what are we going to do with this? Well, there is a technique for dealing with this. What I want you to notice here is that along this row we have a common factor of 2. So now before we said we could just go in and divide by 2. But in the world of finding determinants, you can't just do that because it changes the value of the determinant. What you have to do is instead of dividing through by 2, you actually factor it out. And when you factor along a row like this, it becomes an outside factor for the determinant. So here, if we snag out, you see a 2 from all 3 of these entries, then a 2 will just appear out here. And here's what it looks like upstairs. I just repeated the top and bottom rows, and then out of this row I took the 2, and here's what remains. You see, once I have factored. So now we're in a position, since we have taken that 2 out, and a 1 remains right here, then we can use the technique from before to cause these entries to become zeros. You see, so we go through this group of row operations again. It's negative 3 times row 2 plus row 1 and also plus row 3. We're going to go through it twice. So it's negative 3 times 1 is negative 3 plus 3, 0. Negative 3 times 5 is negative 15 with negative 11 is negative 26. Negative 3 times 2 is negative 6 with negative 2 is negative 8. And then same idea against this third row. Negative 3 times 1, negative 3 plus 3, 0. Negative 3 times 5, negative 15 with negative 1, negative 16. Negative 3 times 2 is negative 6 with negative 1, negative 7. All right, and then away we go with finding this. Now, finding this determinant means, well, let's see, we need to go down a row or a column. We notice the zeros here in this first column. So we're thinking 0 times cofactor, 1 times cofactor, 0 times cofactor. The 0 times cofactors go out. So we have 1 times its cofactor. Now, don't forget about this, too. You see, it's just kind of tagging along as an extra factor, so we just bring it down. And now it's 1 times its cofactor. Now, its cofactor contains a negative sign because of the sign pattern here. It's plus, minus, plus. So that's where this minus sign comes in. And now take out row and column, and we have the negative 26, negative 16, negative 8, negative 7. And now we proceed as we normally would. Now, I have sort of consolidated these 3 ideas. The 2 times 1 times the negative, we could think understood 1 gives the negative 2 here. And then this product, negative 26 times negative 7 is 182. And we're going to subtract this product, the negative 16 times negative 8 is 128. And together that's 54. Negative 2 times 54 is negative 128. So a few techniques to streamline things if we're working with this algebraically. Of course, the fast way to do this is to enter these into the calculator because the calculator can pretty much instantly make the calculation for determinant. You might try that a little bit. I'm not even going to show it because it's such a short kind of little procedure. But that really is the fast track to making these calculations. In fact, since you have your graphing calculator, if you're asked to do these algebraically, go ahead and do them algebraically and then just verify your solutions using the calculator.